All right, so 7.3, there it is. It was recording for 1 second for a long time. The region, the first quadrant, bounded above by the line y equals 2. All right. Below by the curve y equals 2 sine x. Okay, so 2 sine x means it has an amplitude of 2, so it's going to go up like that, down like that. That's y equals 2 sine x. From 0 to pi over 2, well, we know that the period of 2 sine x is 0, it's 2 pi, so that's pi, and that's pi over 2, so that's the first quadrant. On the left side by the y-axis, so we can see that we are dealing with this area, and we're going around y equals 2. Alright, so going around y equals 2 is going to be a solid, so this is going to produce, we're going to use the disk method again for this one, where we're just integrating pi r squared. And since it's a horizontal axis of revolution, then the radius, or the integral, is going to be in terms of x. So pi r squared dx. And we'd be going from here to here, so it's from 0 to pi over 2. So what's left is to figure out what the r, or the radius, is. This is my radius of any given cross-section, which is a circle. So that radius would be, well, we know that this whole distance is 2, and this distance is y, because anytime you're going up from the x-axis is always y, and we could write that y. There's two ways of writing that distance right there. It's either y or 2 sine x. Okay, so either y or 2 sine x. So we choose which of those that fits our integral. We're integrating with respect to x, so we're going to choose 2 sine x for that. So our radius would be this whole minus this part. So the whole is 2, and our part is 2 sine x. So my radius would be 2 minus 2 sine x. Okay. X, and that would be our integral.